Well, good morning, everyone. My name is Jesse Hildebrand. I'm here with Exploring by the Seat of Your Pants. And before I get into my official intro, I've just got to say, watching kids headbang to those songs never gets old. It's one of the true joys of this job. So thank you for grooving along with me to start the day. So, as I said, Exploring by the Seat of Your Pants, we've got a lot of new faces in the crowd today. So if you are new to us, we are all about bringing conservation, adventure, and science into classrooms around the world. We've already done 55 broadcasts this year featuring scientists and explorers the world over. Everything we do is on our YouTube channel. So if you want to hear from hurricane hunters, volcanologists, epic deep sea divers, and more, it's all right there to keep the exploration going. I want to note today, too, that we do have a Kahoot. So between our talk and our Q&A, if you want to play along with a little 4-question quiz, you can pull up that game pin and join us for some fun in between the broadcasts for some epic bragging rights. Now, today I am so excited because we are joined live again by one of my all-time favorite people we ever bring on the broadcast. I was saying to him before we went live that if I could bring him on every week, I would. He is Ravi Prakash, and he's joining us today at NASA's fabled Jet Propulsion Laboratory. Now, the JPL is responsible for making robots that go and explore other worlds in our solar system. In fact, this place is responsible for more of our understanding of the universe than any other facility in the world. So anytime we get to feature scientists there, it is very special. But all the more so today because A, Ravi's awesome. You're about to learn that yourselves firsthand. And B, we just launched the Europa Clipper mission, which he's talking about today, yesterday. Like it blasted off. It's en route to Europa right now as of like 24 hours ago, which is insane. So thank you all for joining us as we get to dive underway on a really exciting topic today with Europa Clipper and Ravi Prakash. Ravi, thank you so much for joining again, man. Welcome back.
Hey folks, yeah, thanks for having me. I love being on this show, so thanks so much.
It is such a pleasure to have you. We've got kids in like Florida, Massachusetts, Newfoundland, Ontario, Maine today. It's like coast to coast. I'm further from you. I'm closer to Morocco than I am to you right now. So we've got like this continental extravaganza lined up, and it's pretty fun.
How fun.
Well, I know you've got a lot to share, so if you want to bring up a presentation and dive us in, let's go for it. And I want to note too, Ravi said before the program, this is his house, and it's like the coolest place ever behind him with like the neatest tech toys of all time. We should all aspire to have a background like that.
Yeah. Usually I'm at JPL and you're seeing something real at JPL. Last year, I actually had this real background behind me. This is just a green screen behind me now. Yeah. But wouldn't it be fun if this was my house?
It'd be pretty cool. Take it away, Ravi. I'll leave you to it, man.
Great. Okay, so Jesse gave an amazing intro. Today I'll be talking about exploring Jupiter's icy moon, Europa. And Europa is one of my all-time favorite places in the universe. But I'm doing something a little different this time than I've done before, which is I'm going to be talking about a mission that I did not work on. And that's just because I am so excited about this. You know, there's always a million projects going on at JPL. Usually I work on the Mars side of things, but this Europa mission is just so exciting, so really cool that I really want to talk about it. And as Jesse mentioned, we launched this mission yesterday, so it's so hot off the press. A little bit about myself. Like I mentioned, I worked a lot of Mars missions before. The first mission I ever worked on was helping to land the Curiosity rover on Mars. This is a car-sized rover. We used a really cool way to land it. It's super cool, called the Psyche. Then after this mission landed on Mars, I actually left JPL and used my engineering skills to design tools to lift people out of poverty. And what I think is one of the coolest things about engineering is that you can use it to solve any problem in the world. And so I could design spacecraft. I was worried, could I help people by designing tools to lift them out of poverty? And sure enough, it's the same design process. And so that was really, really fun. I did come back to JPL because I missed space so much. And so then I worked on the InSight mission, which is on the top right. This is a model of a spacecraft, our test model that I'm standing in front of. And this basically measured, are there Mars quakes on Mars? The answer is yes, there's lots of them, and Mars is very active. Then I went to work on a non-Mars mission called Psyche, which launched actually a year and 2 days ago. And it used 2 of the same boosters that were used on the Clipper mission because SpaceX reuses their launch vehicle boosters. And so, fun fact, Clipper and Psyche have that connection. And so Psyche is on its way to visit an asteroid we think made out of metal. And we're going to be there in a few years. And then in the center of this all is my wonderful family, my 2 daughters and my wife. So Jesse gave an amazing intro into what JPL is. I'm going to just tell you a little bit more. We get to serve the nation by exploring space in the pursuit of discoveries that benefit humanity. So what does that mean? Basically, I get to go into work every day trying to do something that's never been done before and answer a question that's never been answered before. And these things get to benefit people all over the world. We answer questions that people have had since the dawn of time, like, are we alone in the universe? That's one of the questions that the Europa Clipper mission, the one that launched yesterday, is going to try to start answering. There's also lots of spin-offs on the technology that we develop. If you've ever had your temperature taken by one of those ear thermometers, that was the same technology that we invented in order to tell the temperature of a star really, really far away. And then someone really smart said, you know what? I bet we can help people on Earth by taking their temperature in an easier way. And they invented that. And we, of course, inspire kids like you to go into these fields like science, technology, engineering, math, because that inspiration is what causes you guys to invent things that help other people. So the benefit is really amazing of this work. But enough about that. I'm going to talk about this, kind of. This is not Europa. This is Jupiter. And this is an amazing planet. It's, I think a lot of you probably know, it's the biggest planet. A few fun facts about Jupiter. So, Mercury, Venus, Earth, and Mars, they're all rocky planets. Jupiter is made out of gas, and it's what we call a gas giant. And all the planets after Mars, Jupiter, Saturn, Uranus, Neptune, they're all gas giants, and they're huge. But also, something I didn't know, maybe a lot of you know this, something I didn't know until I was probably at JPL, is that Jupiter has rings around it. We all know Saturn has rings, right? Like Saturn is known for having the rings. But did you know Jupiter has faint rings also? It's kind of cool. I didn't know that. And then also, it has a lot of moons, like almost 100 moons. And it's crazy. But the moon, my favorite moon, and the moon we're going to talk about, is Europa. So this is an animation of Europa going in front of Jupiter. And if you have really good eyes, you're going to see a really small dot. We're going to zoom in now. This dot is our spacecraft, Europa Clipper. And we are going to study Europa in a way that we've never studied it before. Now, it's worth noting that this mission is actually going to orbit Jupiter and not Europa, because Jupiter is so big, its gravity is so much, that if we were to try to orbit Europa, we'd have to use so much fuel every time that it would just make this mission really, the spacecraft would have to be too large to launch, or just, it wouldn't last too long at all. So we orbit Jupiter, but we do a lot of flybys of Europa. So now I'm going to show you some close-up pictures of Europa that we've taken from previous spacecraft. This is from older spacecraft back in the day, probably before you were born, actually. So, while Europa is actually a little bit smaller than Earth's moon. So our moon is about 1/6 the size of Earth, so it's pretty tiny. And Europa is a little bit smaller than that. And so it's about the same size, but that's pretty much where the similarities with our moon stop. Europa is an icy world. It's made of ice. There's lots of water. Our moon also is full of craters. Anytime you see a picture of the moon, you'll notice there's lots of craters everywhere, lots of big holes. Europa actually doesn't have that many craters. And so this picture that you see on the right, this was taken by the Galileo spacecraft that we sent in the 90s to explore Jupiter. And it did some flybys of Europa, took some pictures. And the picture that you see here, instead of being covered with craters, we noticed that Europa is covered with long features. And these features are cracks and ridges that go for thousands of kilometers, thousands of miles across the surface. And there's also lots of things like this that we call chaos terrain. And basically, if you were to zoom in here, it looks like icebergs. But here's what's crazy is that because Jupiter is so big and the gravity is so much, the gravity of Jupiter basically breaks apart the icebergs, rotates them, tilts them, and then they freeze in a new position. And that's why we see what we see here. Can you imagine just like being pulled, like these icebergs that are huge, being pulled and rotated and just all sorts of stuff because of gravity? And we see a few things like this. So this is a crater. And there are some craters on Europa. But the reason there's not so many is why we think there's a lot of activity happening in Europa. So let's pretend there were a lot of craters, but maybe something's happening that's causing them to move around, or to maybe the ice melts and then it comes back and freezes over so it's smooth again. There's lots of questions about why there might not be so many craters. Or maybe Jupiter's gravity is taking all these asteroids or comets that would hit the moon, And so it's interesting that there's actually not so many craters, but there are a few. And then there's this fancy word lenticulate, but basically these are pits and spots and domes, and these are places where material from under the surface of the ice might have come out and interacted with the surface. But what I think is the coolest part is this. So all those features that I talked about, plus a lot more evidence, leads us to believe that there's a large global ocean under the icy surface of Europa. And we know from science measurements that this ice layer is about 10 to 15 kilometers thick in some places. And we think there's a liquid ocean of salt water that's about 100 kilometers thick. So, really thick ice, but really, really thick ocean. And then under this, just like Earth actually, is a rocky mantle and then a metallic core. And so, because of water, scientists, first of all, we think Europa contains more than twice the water of all of Earth's oceans combined. So even though it's the size of our moon, it contains more than twice as much water as all of the Earth's oceans combined, which is just a lot of water. And so these oceans, we think, are deeper than the oceans we have on Earth. And anytime we found water on Earth, we have found life. And that is what's really interesting for Europa. But water alone is not enough. You need more stuff. You need other ingredients to have life. And so we are sending a spacecraft to Europa to find out, does it have all those ingredients for life? In addition to water, you need carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfate, all these ingredients that we actually think Europa has, but we need to confirm that. And one of the biggest things you need for life is an energy source. So on Earth, that energy source is the sun. But Jupiter and Europa is really far away. It's more than 5 times as far away from the sun as Earth is. And in fact, it's so far away that from Jupiter, our sun looks like just a really bright star. So when you look out at night and you see like a bright star, that's sort of what the sun looks like from Jupiter, because Jupiter's so far away. And so the sun isn't really going to be that energy source. And plus, under all this ice, there's not going to be any sunlight. And so it's dark. And so actually, it might make you wonder, how is there even liquid so far away from the sun? And that's the interesting part. We think that there might be some sort of hydrothermal vents, just like there is on Earth. At the bottom of the ocean, there is heat coming from the center of the Earth. And we think that same thing is happening on Europa. And we have good reason to believe from these previous spacecraft that there is a liquid ocean underneath. So it's super, super cool for us. And I want to show you an example of maybe something else that's creating heat. So there's something called tidal flexing or tidal heating, and it sounds fancy, but basically, Europa orbits Jupiter every 3.5 days. So it's actually a pretty fast orbit, but it's not a perfect circle. So you'll notice that like here at the bottom, Europa is closer to Jupiter than it is on the other side. And remember, we talked about the gravity of Jupiter is a lot. So basically, the closer you are to Jupiter, the closer Europa is to Jupiter, it's really, the part that's closer is really being stretched towards Jupiter. And then finally, when it's further away, it gets to relax a little. So it's a lot of flexing. It's a lot of moving that planet. And this is the other one is just a side view of that same thing. You can notice that the part that's closer is just getting moved towards, and the part that's further away gets to relax a little. And so sometimes it's closer, sometimes it's further away. And when it's getting stretched, that creates what we call a tidal bulge. And so basically, that creates frictional heating. It's like, when you rub your hands together, that's friction and it gets warmer. Same thing is happening here. It's getting stretched and then not stretched, stretched and not stretched. And that's creating heat also that we think is going to keep that liquid ocean liquid. Yeah. Okay, so I just talked a lot about the planet or the moon Europa, but what about the spacecraft that we're sending? So we just launched the biggest spacecraft NASA has ever sent on a planetary mission to another planet. This thing is huge. And the goal of this mission is to determine whether there are places below the surface of Europa that could support life. So we're not looking for life directly. It's a little tricky. We're not going to look for microbes or sea life or anything. This mission was not designed to do that. It's designed to say, does Europa have the ingredients to support life? And if it does, maybe the next mission we send will say, oh, now I know a good spot to land thanks to Europa Clipper, and I'm going to dig under the surface and explore the ocean and see, is there actually life? That could be a possible next mission if this thing finds, Europa could have everything we need for life. This mission also has 9 instruments, including cameras, a thermal imager, which is basically like night vision goggles to help us understand what areas might be warmer. It has a magnetometer to tell us how deep that ocean is. And what I didn't mention before is that this moon might have plumes of water shooting out over 100 miles from Europa's surface. So imagine that. Like, if you've ever seen, like, I don't know, like Old Faithful or something, you've heard of that. Like, it's this geyser that just shoots a bunch of hot water out from the Earth. This thing is shooting plumes of water over 100 miles from the surface. And this spacecraft is going to fly as close as 16 miles above the surface of Europa. So through those plumes, if they're there. And we do have instruments that can sort of take in those particles, literally take in those particles, smell those particles, take them in, sample that material, and tell us more about what's beneath the surface of Europa. So it's super, super cool, this mission. I think we're all so excited for it. And like I mentioned, this thing is big. And why is it so big? So, I mentioned it uses solar panels for energy. And so far away from the sun, you got to have really, really big solar panels to capture that energy. And so when we extend, in fact, we extended our solar panels yesterday. Things are looking good. When you extend those out, it is bigger than a basketball court. So next time you're at a basketball court, picture a spacecraft centered right in the middle of the court, and the solar panels are going past the goalposts. And that's how big Europa Clipper is. It's huge. And it's really huge because we need big solar panels to get that energy from the sun and power our mission for a long, long time. Now, the biggest challenge of this mission is that Jupiter has so much radiation. In fact, it is just, like every time you get an X-ray or every time like those sort of things happen, you get radiation, and it sort of accumulates in your body over time. And same thing happens to the spacecraft. The more it gets radiation from Jupiter, the more it's going to just accumulate. And eventually that degrades electronics, your computer, and all that stuff. And so we have this thing we call a vault, which is made of really thick metal, and it just protects the instruments as long as we can, but it can't protect it forever. And so this animation is going to show you Jupiter's in the middle here. This is our spacecraft. When it's in this color, like this, pink, purple color, that means like, okay, like a little bit of radiation, but it's okay. And every time it gets close to Jupiter, you'll notice this little thing goes up, up, up. And we have this total dosage of radiation on the bottom here. Okay, it's getting greenish. Okay, it's getting a bit more radiation. You can tell from this key down here. Yellow, orange. When it gets to red, okay, that's a lot of radiation. And so we are planning 50 passes of Europa, at least. And that's going to accumulate a lot of radiation. And so the engineers that worked on this project had to be really clever about how to make sure that we really minimize the damage from the radiation. Yeah, so these are just all the orbits that we are planning on doing while we are at orbiting Jupiter and while we're at Europa. Okay, so like we said, we launched yesterday. What does the path look like? So we are actually going to pass Mars in just over 4 months, which is really, really fast. And it's going to fly by Mars and get what we call a gravity assist. So every planet has gravity. And as you approach it, that gravity pulls you in and speeds you up. And you can use that to your advantage to go faster. So what we do is we fly by Mars and get a big gravity assist. So we go much, much faster. Then, we're orbiting the sun. We actually take advantage of flying by Earth again So it almost sounds like we're going backwards, but we're not really going backwards. We're actually, we're just taking advantage of another gravity assist to get to Jupiter even faster. And so Mars will pass in 4.5 months. Then we fly by Earth. That'll be like, almost 2 years later, we'll fly by Earth. And then that will shoot us out to get to Jupiter in 2030. So 5.5 years from now is when we'll be at Jupiter. And that just shows you how far away Jupiter is. So like Mars, we are passing Mars in 4 months, but it's taking 5.5 years to get to Jupiter because Jupiter is so far away. And then when we get to Jupiter, we'll do all those cool little orbits that we saw on that previous slide. And then this is my last slide. So there are ways for you to get involved, and it's really cool. You can go to this website, europa.nasa.gov/participate. And there's a lot of cool things. There's an immersive AR experience, augmented reality. There's coloring sheets. There's this really, the Nobel laureate, the poet laureate of the US wrote this poem that's in her own handwriting on the spacecraft on a sheet of metal. And it's amazing. You should check it out. And you can write your own space poetry and submit it. And that's really fun. There's also, you can make 3D models. They have cutouts you can do for paper, and you can build, using Legos. It teaches you how to make Europa Clipper. Lots of really cool things that you can do on that website. So check it out. That's what I have. I'm going to quit sharing here, and then I would love to answer a lot of questions that I hope you all have.
Amazing, man. Well, thank you so much for that. I didn't know Amanda Gorman's the poet laureate. Yes, I'm not crazy.
She was, and there's someone else now. And
new poet. All the poets. That's fun. There's a long tradition of NASA spacecraft having messages from humanity. Or Voyager records are sort of one of the iconic examples of this. The golden record on Voyager is one of my favorite things in the history of science exploration. Yes. So the fact that we're continuing that tradition with this is so special. Very cool, man. Well, thank you so much for all of that. We are going to dive in with questions in a minute, but first, we're going to test some understanding and have a little bit of fun with the kids with our Kahoot together. So, for those new to Kahoot, the faster you answer, the more points you get. Ravi, you can give us little hints in the final few seconds of each of these if you'd like to. And what they win is our everlasting respect. So if you want to play along with the Kahoot, if you want to yell out in your class, that's totally fine. We're going to get underway in just a second, and then we are going to head to Mr. Paul's Great Sixes for our first question after that. Phoenix School, Miss Breton, our YouTubers, you guys can get ready as well. But I'm going to bring this up and get underway. Let's do this thing and get started. All right. Question number 1 in 3, 2, 1. Here we go. How long will it take Europa Clipper to reach Europa? We just covered this. Is it 6 days, 6 weeks, 6 months, 6 years, more or less? We're not quite on any of these, but let's see what our option is. Get those answers in. 5 of you so far. Fantastic. Now, again, the moon is like 2 to 3 days. Mars is like 5 to 8 months, typically, I would say, in the missions I've heard of in the past. So, yes, you guys almost all nailed this. It's 6 years. Jupiter's really far away, even with the fastest spacecraft, even with that extra speed boost we get from the Earth and Mars. Like, it's wild. I like highlighting this for the scale of space, Ravi.
Yeah, I agree. It's amazing.
So, Lively Dingo's in our lead as we go to question 2. Let's see. All right. Europa's a moon of which planet? We covered this a lot. This is an easy one. I'm giving this as a gimme. We got all the planets and our dwarf planet Pluto there for good measure. But is it Mars, Jupiter, Saturn, or Neptune? I want to note, though, and this might lead into one of our next questions, there are other moons on other planets that are also really interesting candidates for water, life, and beyond. So we might cover that next. Stay tuned. But Jupiter is our answer. Yes, there is a cool moon of Neptune called Triton, which is awesome. Maybe not where we're looking for life, but I like you guys are doing really well. All right. Question 3 is Focus Glider takes our lead. True or false? I just talked about this. Europa Clipper uses gravity from other planets to slingshot it farther into the solar system. I find this, I've known this for years now, and every time I think about it, it's still mind-blowing that we can do this and that we can chart that orbit. If you picture throwing a dart at a dartboard, that is so much easier to get a bullseye 1,000 times in a row than to navigate a spacecraft through the immensity of the solar system and swing it out to Jupiter through gravity assist. Like, the margin of error is like so small. It's crazy, Ravi. You guys are so cool.
It's amazing. Yeah.
All right, with our leaderboard with Focus Glider in the lead, going to our final question, a very tight lead. Question number 4, multi-select. We did not cover this. I'm just testing space and just generally. What other places in our solar system are prime candidates for finding life? I'll give you a hint. It's more than one. It might be 3. It might be 4 of them. But Mars, Enceladus, which is a moon of Saturn, Titan, which is another moon of Saturn, or the sun itself. Where might we find life? Let's see what we get, everybody. One of them might be a little too toasty. Woo! You guys did really well. Like almost all of you got this, which is really impressive. I didn't expect that. Way to go, everybody. So yeah, Ravi, really briefly, as we pull up our podium here, Enceladus and Titan, are there any missions planned for those? Can you tell us a little brief overview of those in 2.2 seconds?
Yeah. Titan is really, really cool. So it's a planet, it's a moon of Saturn, and we are sending a quadcopter there. So it's a quadcopter that the Applied Physics Laboratory, APL, is designing, and it's going to be super cool. It's going to launch, hopefully, I think in maybe the 2030 timeframe. I forget exactly when. It takes a long time to design these things. It's super complicated, but it's extremely exciting.
Amazing. Titan's very cool. Titan's got like lakes full of methane. Like it's too cold for water, but it's got lakes of hydrocarbons, which is insane to even think about. So we'll have to do a whole other program on that with you in the future, man. But let's dive in with questions. Thank you so much again. Lively Dingo, kudos to you. If you are Lively Dingoes, let us know who you are in the chat. We're going to head to Mr. Paul's class in Meadows, Newfoundland here on the West Coast. Come on in and take us away with your first question. Hey, guys.
Good day, Ravi. It's very nice to meet you. Can you guys hear me okay?
Yeah, you're perfect, man.
Awesome. Ravi, it's really nice to meet you. Jesse speaks very highly of you. We have a question from one of our students, Paul. I'm going to sit Paul in my seat now, and he's going to ask the question. So it's really
Come
nice
on in, Paul.
Do you think that there could be life or fish on Europa or even anywhere?
Oh, one of my favorite questions. Thanks, Paul.
That is a great question. I think there could be, I don't know if it's going to be like bacteria type life, little germs, or if it's going to be like actual sea life under Europa. What I know from Earth is that even in places we thought life could never exist, life finds a way to exist. And so I've got to believe that it looks like Europa has those ingredients for life. Europa Clipper will confirm that or not. And I think it's going to be, I think we're going to be, one day when we go under that ocean, we're going to be very, very happy to see other life.
I want to say that we have a lot of NASA explorers, engineers, astronauts, etc. come on, and it's a universal from people involved in the space field that given the immensity of space, how many planets, how many moons are out there, that there is life elsewhere in the universe. The challenge is finding it, but it's so exciting that we finally have this mission that's going to get us one step closer to getting underneath that ice into that ocean in the future to hopefully uncover that. That's a great question, Paul. Thanks, man, for kicking us off. We're going to head to the Phoenix School, Mr. Morrow's class. Come on in, unmute your mic, and you can take us away with the next question. Hey, guys. Welcome in. Hi. You're almost good. Just unmute. Wants to work. Just thinking about it.
My name is Jay, and I'm in 6th grade, and I have a question. You said that the water shoots out from Europa. Would that hit the spacecraft?
Yeah.
And like knock it down?
Yeah, it possibly could. Space is big. Europa is, even though it's the size of our moon and maybe seems small, it's a big thing, right? And so the chances of there being a plume right when our spacecraft is going may be small, but we would love it if those plumes actually just completely cover the spacecraft. We have instruments designed to take that stuff in and assess what that ocean is made of. It wouldn't harm our spacecraft. We would be ready for it. So yeah.
Cool. And there's no version of events where it harms the spacecraft? Because that's a question that I've heard talking to a lot of family and friends about this mission. Like, there's no chance to just blast it off into space? You're going too fast for that to happen, or what?
Exactly. Yeah, that's right. We are heavy and we are big, and this is stuff that wouldn't be able to affect us. Even if it affected the trajectory, we have rockets that would just put us right back on course.
Quick query on this. We classically, when we talk about spacecraft speeds, they go many times faster than a bullet. And so I don't know how much it has to slow down to get into Jupiter's orbit at the end, but it still is going well faster than like a rifle bullet, right?
Yeah, we're talking like 10 times faster or even more. These things are amazingly fast.
Insanely fast, which underscores at that speed, it still takes 6 years to get to Jupiter. Space is huge. It's ridiculous. Great question, man. Miss Breton's class, we're going to head to you, and then we're going to do a whole other round. YouTubers, you can chime in too. Please do share as many as you can, but come on in. Grade sixes.
What have you explored of the moon Titan?
Ooh.
Yeah. So we have sent spacecraft to Saturn, and those spacecraft have done flybys of Titan and taken pictures. But the coolest thing we did was there was a mission called Cassini. And Cassini was a mission to orbit Saturn, but the Europeans put a probe on Cassini called the Huygens probe. And this probe, it went into Titan, and it took pictures on the way down. It took pictures from the surface. And so we've actually been on the surface of Titan. It lasted maybe hours or so, maybe at best days, I'm forgetting. But it really told us that Titan is an amazing place. We do want to visit it again, and that's why we're building a mission to go there again.
I want to highlight for our kids too, because one of my favorite images, one of the most iconic images in the history of science, was when we sent Voyager out and it took a picture back from Saturn towards the Earth, and you see how tiny the Earth is in the scale of the solar system. Well, during the Cassini mission, when we went back to Saturn and Titan, we took a better picture of that. So it's like this insane picture where you get like the scale of Saturn, and then there's this little pale blue dot. It looks like a little pinprick in the picture, and that's us. That's the entire Earth. And it's one of the coolest things ever. Look up pale blue dot Cassini. I promise you will not be disappointed when you're done this broadcast. All right, we're going to head back to Newfoundland. Come on back in Mr. Paul's class. Unmute your mic and take us away, man. Hey. But unmute. There we are.
Can you hear me now? Okay, Jesse?
Yeah, perfectly, man.
Awesome. So do we have time for maybe one more question?
Yeah. Go for it.
Awesome. Do you have one for me, King? Just 1 second.
Take your time, man.
Okay. So the question from one of our students, Kaylin, is, Ravi, question, will people be able to live on other planets?
So I think, there are a lot of challenges if we want to live on another planet. So humans need food, water, air, and those are some of the most essential things. Right now, we don't know how to grow food on another planet, or to extract water from a planet in large amounts, or how to have oxygen. A place like Mars, for example, might be one of our best chances because it's relatively close to Earth, and NASA and other companies are looking into what's it going to take to put people there and have them survive. It's going to happen eventually, and the question is, can we send, how much food and water and air do we need to send, and how much can we just do it from Mars itself? The more we can do at Mars, the easier it is to get there and go. Otherwise, you have to take so much stuff with you. And so that'll be the biggest challenges.
Yeah. I want to stress too, like, this is the golden age for being interested in this. Like, the kids in your classes right now, you grade 6 kids, are like the age that are the likely people to be at the age of astronauts when we're going to Mars, which is insane. We're going to the moon again next year. We're going to go circle it, including with a Canadian astronaut for our Canadians in the crowd. And then 2026 is like our benchmark right now for landing back on the moon for the first time since 1972. So we've got the coolest robotic missions. We've got the coolest manned missions. Like, this is the time to be interested in this. And I want to stress for all our classes, like Ravi, you highlighted jpl.nasa.gov. The Europa website is right here. NASA has the coolest resources ever. No government agency has ever invested more in cool education than NASA. So do check those out when you're done the broadcast. They're very special. Ravi, we're going to head back to our Phoenix School friends. Our Ontario group had to say farewell, but they are really excited. So come on back in Salem. Take us away, guys. Unmute that mic. So many hands.
Love it.
We'll take multiple. Don't worry. We're going to get more from everybody. Come on up. Hey.
Hi, my name is Leon and I'm in 4th grade. And my question is...
You're not in 4th grade.
Yeah, I said 5th. My question is, what type of engines are you going to be using for the rocket?
Yeah. That's a great question. Yeah, we have different types of engines. Like for the Psyche mission, for example, is using something called ion engines, where we shoot particles out the thing. This one uses traditional chemical stuff. So it's like the same way when you see a rocket launch and fire is coming out That's how we are getting into towards Jupiter. And then once we're there, we have small little thrusters that just shoot out. I don't know exactly in this case. Sometimes it's cold gas. It might be cold gas, I think, that we shoot out to orient the spacecraft and have it head in the right direction. So it's probably cold gas thrusters, is my guess.
Very, very cool. Nice question, guys. We're covering all the space missions. By the way, if you want to check out Ravi talking about Insight, Curiosity, other Mars missions too, he's on our YouTube channel. Like, we've got lots with Ravi. He just doesn't stop. And if you're keen on Psyche, which we talked about as well, some other cool missions, they're all on our YouTube channel to keep the learning going when you're done. So special. So please do take the opportunity to check that out. Phoenix School, we're going to head back to you guys. People are heading to lunch in droves. So we're going to head back one more time with you before we wrap up for the lunch hour. And then we'll say a big thank you and farewell after that. Come on back in, guys. Mr. Morrill's crew. I always love when we have kids from all these age groups in one group. You guys rock. It's always fun having you on, honestly. Who gets the next question? Eeny, meeny, miny, mo. Again, I'm going to pass along to all our teachers YouTube, StreamYard alike, the Europa link. You can check out Cassini's pale blue dot picture. I'll pass along a whole bunch to keep the excitement going when we're done. And we've got some other amazing NASA programs coming up this month as well. So, Phoenix School, unmute, take us away.
Hi, I'm Audrey. I'm in 8th grade. And my question is, I saw a video of a woman talking about how there are new spacesuits that they're inventing. Are you guys making a special suit for the mission that has adaptations to survive where you're going?
Oh, I love that. NASA is making new spacesuits for the people going to the moon and Mars. The mission I talked about is actually just a robotic mission. So we're not actually sending people to Jupiter or Europa. This one is a robotic mission just to learn more about the planet and the moon. So we don't need spacesuits for this one. But yeah, absolutely, NASA is designing spacesuits that are better than the ones we've had before and more functional for Mars and the moon.
They look very cool. I've got to say, the new missions, they like rock stars going into space. It's very fun. Ravi, thank you so much for all of this. Time flies when you're having fun, so we're nearing the end of the broadcast. Is there any final message about Europa Clipper, anything you want to leave us with before we wrap up and say farewell for the day?
Yeah, I think I will say that, if you found this mission cool, these missions, it takes a long time. By the time we probably get around to designing something to land on Europa, it might be one of you guys that's doing it. And so if you're into space, into NASA, work hard, do well in school, and get this job, and maybe you can be designing the mission that's going to find life under the surface of Europa.
I mean, I've got a pretty cool gig, but I might have to go and do that and come down to California and see if I can help out. Ravi, thank you so much, man, for our students. Abigail Freeman's coming on to talk about Mars. Aaron Yadley's talking about engineering. We've got Paige Arthur on Psyche this month alone. Like, it's an epic NASA month of space exploration, so please do come back and join us. We're going to wrap up the broadcast there. Phoenix School, if you want to unmute your mic and join us in saying a big thank you and farewell. Ravi, you can stick around with me after the broadcast for just a second. But Phoenix School, Mr. Paul's class, Ms. Bretton's class, all our YouTube audience, thank you guys so much. Have a wonderful rest of your day. Bye for now, guys. Thank you so much.
Thank you, everyone.
Farewell.